Welcome back, Professor Bright here, and we are still talking about functions. But the thing is, we've talked about a fair number of forms already. Tabular, we saw in the last one. That's just creating an XY table. Move on. Graphical. Remember past, passive, vertical line test. We've kind of touched on the descriptive form. That's remembering the definition, all that sort of thing. But we want to focus on the algebraic representation in this video. So first of all, let's assume we just have a function. So more than that, though, we assume that y is a function of x. And so when we do this, when we say this language, we're actually naming the function. The function, a relationship between x and y needs a name, and so you have to give it a function name, and, well, we generally stick to f. If you want to call it g, h, k, j, m, n, o, p, whatever. Fine. Okay. You need to give it a name, though, because there could be more than one type of function between x and y or whatever variables you're working with. Okay, so when we use this notation, it's actually, in my experience, students get hung up on x and y, so I like to use symbols instead. And so what I think of it is, you have square, okay, you have to put square into rule f. Okay, so imagine you have on this little conveyor belt, this little machine, you have square, that's what you have to start with, and then you put it into this rule, and then out of that you get triangle. Okay, so that's talking about inputs, outputs, domain, and range ideas. Okay, and so square and triangle, they are symbols, they can change, right? And so that just means we can put something else in if we need to. Just remember that if you change whatever you put in, you have to, or we have to, replace all x's, or the inputs, with the new amount. Okay, so as an example, here's a function. X squared minus 2x plus 1. Nice quadratic function. See those later. Okay. If we want to find f of 2, this is called evaluating the function when x is 2. Okay. What we have to do is take, now again, there's an x here, there's an x here. Those both get replaced with a 2, and so I like to put parentheses in there, even though you maybe don't need them. Okay. And then we can evaluate and we get 1. Okay. Cool story. Negative 2, same sort of thing. Parentheses are super important here because if you forget them, you're going to forget the negative, just square the negative, and 2 minus 2 plus 1, and this time we end up with 9. Okay, and then now finally, this one's a little different because we have two things, but again, the principle is the same. Wherever there was an x, it gets replaced with whatever I put in, so minus p plus 1 squared. And then minus 2 minus p plus 1, okay, plus 1. And now here, I'm going to do dot, dot, dot for time purposes, and I'm assuming we've seen algebra. If you need some help working this out, certainly ask in class and we can go through that. And what I end up with at the end here is p squared minus 2. Okay, make sure to do that on your own and check. All right, so few examples are done. I want you to pause the video and try these on your own. And there we go. There are the answers. Now, the process of evaluating functions, a little tedious, yes. It's a good skill to just kind of do to practice. Okay. Now, when we evaluate some of the functions, it's often that we want to evaluate f of 0. Why is that common? Well, if we think about f of 0 and what it means, well, f of 0, this is just saying that when x is 0, what does y equal? Okay, and the really nice thing about this is that it eliminates variable terms. Because when x is 0, you just eliminate all the variables, and they all get multiplied by 0, and then you're just left with whatever constants. So that's why this one is common. Okay, now, what are the other ones that are common? Okay, well, maybe some that you'll see in a second here. I want to talk about intercepts. When we do f of 0, that's actually finding one of the two intercepts of a function. Okay, the idea, the x-intercept, it's a point. I have to stress it as a point. So when you report it, it is a point, not a number. Okay, it is a point, a comma 0, and we find it by solving f of x equals 0. So again, you have to let, in this instance, this is really saying when f of x is 0, this is really saying y is 0. So to find the x-intercept, let y be 0, and then when we want to find the y-intercept, it's a point 0b. Notice that x is 0, right? So then we're putting x into 0, or x to 0, and solving from there. Okay? So the rule of thumb, whichever one you want, set the other variable to 0 and solve. Okay? So if we want to find the x-intercept, or the intercepts of this, we need to find the x-intercepts. I'm going to just do x-ints, and I'm going to do the y-ints. Okay? The y-intercept is going to be super quick. So this one means x is 0, so then f of x really is y. So I say y is equal to 0 minus 2 squared minus 1. And when I crank this down, I get 3. So then the y-intercept is a point 0, 3. Okay, so that's one intercept. For the x-intercept, this is when I would let y equal 0. So this would be solving the equation 0 is equal to x minus 2 squared minus 1. Add 1. 1 is equal to x minus 2 squared. You could also FOIL this out if you wanted to. I'm going to do a different method. Square root both sides. When you introduce a square root, remember you need the plus and minus. Plus and minus x minus 2. So then we end up with two equations. X minus 2 is equal to positive 1, and we also end up with x minus 2 is equal to negative 1. Solve each of these. X is equal to 3, and x is equal to 1. So then here I get the point 3, 0, and from here I get the point 1, 0. And that is how we find the intercepts. Okay? So intercepts, whichever one you want, set the other equal to 0, and solve. And then other than that, it's all about function evaluation. So get practice with the notation, and we will certainly get some practice in class.